Our planet, Earth, a pale blue dot suspended in the vastness of the cosmos. But what if I told you that our planet is not just a lonely speck in the universe, but rather intricately connected to the cosmos? You see, we are all made of stardust, particles born from the explosive deaths of ancient stars, the atoms that make up our bodies, the air we breathe, and the Earth we call home were once forged in the hearts of stars billions of years ago. Our planet is a cosmic masterpiece, the result of the universe's remarkable processes and evolution over billions of years. As we gaze upon the stars, we are reminded of our profound connection to the universe and how we are just tiny particles in this grand cosmic tapestry. We are bound to the cosmos, and the universe is woven into the fabric of our existence. So let us cherish and protect our planet, this pale blue dot we call home, as we continue our cosmic journey, forever connected to the vastness of the universe. The Critics Show presents Eternity, revealing the mysteries of the universe. Join us on an epic cosmic journey as we explore the vastness of the universe, guided by the legendary voice of Morgan Freeman. In this episode, we embark on an awe-inspiring introduction to the universe, unlocking its secrets and uncovering its mysteries. The universe is an infinite expanse of space and time that has fascinated humans for centuries. In this series, we embark on a journey through eternity, exploring the wonders and mysteries of the universe. Our journey begins with the Big Bang, the event that brought the universe into existence. The Big Bang occurred approximately 13.8 billion years ago, and it marked the beginning of the universe as we know it today. The Big Bang theory is supported by various lines of evidence, including the cosmic microwave background radiation, the abundance of light elements in the universe, and the observed expansion of the universe. One of the most important pieces of evidence supporting the Big Bang theory is the cosmic microwave background radiation. This radiation is a remnant of the early universe. The cosmic microwave background radiation is a critical piece of evidence that supports the Big Bang theory, as it shows that the universe was once in a hot and dense state. Another piece of evidence supporting the Big Bang theory is the observed expansion of the universe. In the 1920s, astronomer Edwin Hubble discovered that galaxies are moving away from us at a speed that is proportional to their distance. The Big Bang theory was first proposed by Belgian astronomer Georges Lemaitre in 1927. But it was not widely accepted until the 1960s. Einstein's theory of general relativity provided the theoretical framework for understanding the Big Bang. Our journey through eternity has just begun, and there is still so much to discover and explore. Join us as we continue to unravel the mysteries of the universe. This is the story of galaxies and stars. A story that began with a bang, the Big Bang, about 13.8 billion years ago. The universe was born in a colossal explosion that created space and time, forming the first atoms of hydrogen and helium. But what about galaxies and stars? How did they arise from this primordial soup? And how did they shape the evolution of the universe? And what does the future hold for them? To answer these questions, we need to travel back in time. Back to the very beginning of our cosmos. For the first 400 million years, the universe was dark and silent. There were no stars or galaxies, only clouds of gas and dust that collapsed under their own weight. As the gas and dust heated up, nuclear fusion ignited at their cores, giving birth to the first stars. These stars were massive and bright, shining like beacons in the dark. They formed clusters and groups, which eventually merged into larger structures called galaxies. Galaxies are collections of billions of stars held together by gravity. They come in different shapes and sizes, such as spirals, ellipses, and irregulars. Our own galaxy, the Milky Way, is a spiral galaxy with a central bulge and four main arms. The Milky Way is home to about 200 billion stars, including our Sun. It is also part of a larger group of galaxies called the Local Group, which contains about 50 other galaxies such as Andromeda and Triangulum. Galaxies and stars are not static. They change over time, influenced by various factors such as gravity, radiation, collisions, and feedback. Some of these factors can trigger new star formation, while others can quench it. For example, when two galaxies collide, their gas and dust can be compressed and stirred up, creating new stars in a burst of activity. This can also result in a change of shape or structure for the galaxies involved. On the other hand, when a galaxy runs out of gas or is stripped of it by its environment, its rate of star formation declines, and it becomes more red and dead. Stars also have different lifespans depending on their mass. Low-mass stars like our Sun can live for billions of years, while high-mass stars can die in a few million years. When a star runs out of fuel, it can end its life in different ways, depending on its mass. For example, when a low-mass star exhausts its hydrogen core, it expands into a red giant and then sheds its outer layers into space, forming a planetary nebula. The remaining core becomes a white dwarf, a dense remnant that slowly cools down over time. When a high-mass star runs out of fuel, it collapses under its own gravity and explodes in a supernova, releasing enormous amounts of energy and material into space. The explosion can also leave behind a neutron star or a black hole, depending on the mass of the core. Planetary nebulae are beautiful clouds of gas and dust that surround dying stars. They come in various shapes and colors, depending on the mass of the core. Planetary nebulae are beautiful clouds of gas and dust that surround dying stars. They come in various shapes and colors, depending on the properties of the star and its environment. Supernova are powerful explosions that mark the death of massive stars. They can outshine entire galaxies for a brief period of time and be seen across vast distances in space. Neutron stars are extremely dense objects that result from the collapse of massive stars. They have strong magnetic fields and spin rapidly, emitting beams of radiation from their poles. Some neutron stars are called pulsars because they appear to pulse as their beams sweep across our line of sight. Black holes are regions of space where gravity is so strong that nothing can escape, not even light. They are formed by the collapse of very massive stars or by the merger of two smaller black holes. They can grow by accreting matter from their surroundings or by merging with other black holes. For example, as galaxies move away from each other due to cosmic expansion, they will become more isolated and less likely to interact or merge with other galaxies. This will reduce their rate of star formation and make them fade away over time. These stars will also face a similar fate. As they consume their nuclear fuel, they will change their brightness, color, size, and shape. Depending on their mass, they will end their lives in different ways, leaving behind various remnants such as white dwarfs, neutron stars, or black holes. Eventually, all stars will die out, leaving behind a cold and dark universe filled with stellar corpses and black holes. These remnants will also decay or evaporate over extremely long timescales due to quantum effects such as proton decay or Hawking radiation. Finally, if the universe reaches thermodynamic equilibrium, a state in which the temperature approaches a uniform value, no further work will be possible, resulting in the final heat death of the universe. This is the story of galaxies and stars, a story that spans billions of years and trillions of light years, a story that reveals the beauty and diversity of nature.